Hello students, today we will discuss about the BSc second year semester 3 thermodynamics from block 1 unit 2, that is zeroth law and first law of thermodynamics we are going to be discuss. So before going to discuss about the zeroth law and first law of thermodynamics, we should know what is thermodynamics, and in that we should know about the terms which we should understand, because if you want to understand the zeroth law of thermodynamics and first law of thermodynamics continuously, we have to know about some terms. We will be discussing about the terms, and as well as then we will move to the zeroth law and first law of thermodynamics. So now we will start actually introduction about the thermodynamics. Then what is thermodynamics we will see here. So if you take this thermodynamics, thermodynamics is a branch of physics which deals with the transformation of heat energy into mechanical work and vice versa. That means sometimes this heat energy is converted into mechanical work, and also the mechanical work can be converted into heat energy. So that is the reason why we will be calling the thermodynamics is a branch of physics which deals with the study of transformation of heat into work, and as well as the other forms of energy we will call. So if you take this thermodynamics, so thermodynamics mainly focused on the macroscopic science. That means the quantities which are able to know directly without in microscopic. So which are knowing directly, that is which we can able to touch and like that. So this thermodynamics mainly deals with the macroscopic terms. Otherwise we can say that thermodynamics deals with a macroscopic science. So it does not go in detail into the what we call microscopic structure, that is the how the molecular constitution of matter has done, that all we do not see, but only we will go into the macroscopic things, and as well as we will be study about the bulk systems we are going to be study here. So that is what we have about the thermodynamics. Next we will see what are the terms which we required in order to understand the thermodynamics. So we can say that the basic concept which are there in the thermodynamics, otherwise we can say that the thermodynamic terms we should know about that one. So first we will be studying about what is system, because we should know about the system, when only we can understand the zeroth law of thermodynamics as well as the other laws of the thermodynamics. If we want to understand, we should know about the system. So here in the thermodynamics, if a system, if you want to understand, so if you want to define a system, we can say that a thermodynamic system is a specific portion of matter with a definite boundary on which our attention is focused. That means system means which we are going to be study about the thing which is focused only, otherwise we can say that particularly on one thing we are going to be see, that is what we will be calling it as a system. Suppose if you take an example of a system, if you consider this room as a system, if you consider whatever may be the things which are present within the room, we can call it as a that belongs to this system. So that is particular things or particular things whichever are there within that system, we are going to be focused here. So next if you take if you study about the system, so mainly there are some types of systems are there. So we can say that mainly there are three types of systems are there, which we can call it as a isolated system, or closed system, or open system. So these are the main three systems which we have. So if you coming to know about this isolated system, so this isolated system if you take, so this isolated system cannot exchange energy matter with surroundings. So this system, isolated system, whatever may be the things which are present that belongs to within that system only, they cannot move to the surroundings. So mainly exchange of heat energy as well as the matter cannot be done with the surroundings in the case of the isolated system. The systems will belongs within that only. So that is what we call it as a isolated system. Coming to this closed system, so if you take the closed system, an isolated system cannot exchange energy mass with surroundings, whereas in the case of the closed system, in this the energy can be exchanged with the surroundings, but whereas the matter or mass cannot be exchanged with the surroundings. That is what we will be calling it as a closed system we are going to be called. And coming to the third system whichever we have, so which we call it as a open system. So if you consider this open system, in the open system the mass as well as the energy, otherwise the matter as well as the energy, both can be transferred with the surroundings. So otherwise we can say that the energy as well as the matter can be transferred from the system to the surroundings, and as well as the from the surrounding to the system, this energy as well as the matter can be transferred. That is what we call it as a open system. So these are the three systems which are there. We will focus in the thermodynamics, which we call it as a isolated system, a closed system as well as the open system. In the case of the isolated system, we said that we won't transfer anything from the system to the surroundings, or we won't take anything from the surrounding to the system. Mainly the energy as well as the matter or mass, we cannot be transferred from the system to the surroundings or from the surrounding to the system. That is what we call it as an isolated system. Whereas in the case of the closed system, if you take, in the case of the closed system, we can transfer the energy from the system to the surroundings or from the surrounding to the system. But whereas matter or mass cannot be transferred from the system to the surroundings or surrounding to the system. That is what closed system we have. And coming to this open system, as I told that both energy as well as the matter can be transferable from the system to the surroundings or from the surrounding to the system. So these are the three systems which we have in the thermodynamics. Next we will be focusing on what is surroundings. So both the system as well as the surrounding, they are interrelated to each other. So whenever we are talking about the system, we should talk about the surroundings as well. So surroundings is nothing but the things which are present outside of the system, the things which are present outside of the system, and as well as they can influence the behavior of the system. They can influence the behavior of the system. That is what we call it as a surroundings we can call here. Suppose if you want to define the surroundings, so everything which is outside of the system has a direct influence on the behavior of a system is known as surroundings we have. So if you take this room, if we consider as a system for us, so whatever may be the things which belongs to within the room, we can call it as a system for us. Suppose the things which are outside of this system, whatever we have, those are surroundings for us. Suppose if a person who is outside of the system, for him that is the system, we are the surroundings. So that means the system and surroundings whatever we have, they are not same for every person. That means within this system, suppose if you consider this as a room as a system, if you consider that room is system for us, and whatever may be the things which are outside of the room, we will be calling it as the surroundings. For us this is a system, and outside of this whatever we are going to be have, we will be calling it as the surroundings. Suppose if you have a person who is outside of this system, for him that is the system for him, whereas we are surroundings. So that means for the same person, for different persons, the system and surroundings may vary. So that is what we have to see here. Both when we are talking about the system, we should know about the surroundings also. That is about the surroundings. Next, another term which we should know when we are studying about the thermodynamics is, we should know about the thermodynamic process. Okay, we should know about the thermodynamic process. So thermodynamic process is nothing but if a system undergoes a thermodynamic process, when there is some energetic change within the system that is associated with the changes like in a pressure, volume, temperature, if you changing, then we can say that the thermodynamic process is occurring. That means whenever a process is occurring, like pressure may be changes, volume may be changes, or internal energy may be changes. So in the process these may changes here. Okay, by keeping something constant, in some cases some process may be temperature constant, the remaining may changes. In some other process volume may be constant, remaining may be changes. In some other process some other internal energy may be constant, the remaining things may be changes. So this is what we call it as a thermodynamic process we are going to be called here. So that is we should know when we are studying about thermodynamics. So if you see about the thermodynamic process, a system undergoes a thermodynamic process when there is some energetic changes within the system that is associated with changes in pressure, volume and internal energy, as we already discussed. So, there is a changes in the pressure, volume and internal energy. So, if you take this thermodynamic process, there are 4 types of thermodynamic process are there. So, these 4 types of thermodynamic process what we have is adiabatic process, isothermal process, isobaric process as well as the isochoric process. So, these are the 4 types of thermodynamic process are there. So, in each process, the things which are going to be kept constant will be different, the things which are going to be changes may be different. Suppose coming to this adiabatic process, in the case of this adiabatic process, the heat energy, otherwise heat is constant in this process. That means there is no heat transfer from the system to the surroundings or from the surroundings to the system is going to be takes place. So, if you want to define the adiabatic process, the thermodynamic process in which there is no heat exchange from the system to the surroundings or from the surrounding to the system, that process we will be calling it as a adiabatic process. So, in the adiabatic process, heat transfer will not takes place, that is going to be constant. That is what we will be calling it as a adiabatic process we are going to be called here. And coming to the next process which we have, like a isochoric process if you take. So, in the case of the isochoric process, the volume is going to be constant. That means there is no change in its volume, there is no change in its volume. So, a process where no change in volume occurs and the system does no work. So, we have to remember that in the case of the isochoric process, there is no change in volume occurs and the system does no work. That means no work will be done in the case of the isochoric process and the volume is going to be kept constant here. The change in the volume is 0 in the case of the isochoric process. That is what we call it as a isochoric process we are going to be called. And coming to the next process which we have, isobaric process. In the case of the isobaric process, there is no change in the pressure occurs. So, the pressure is going to be constant in the case of the isobaric process, the remaining things may be changes. That means a process in which there is no change in the pressure, we will be calling it as a isobaric process we are going to be called. That is one type of process in the thermodynamic process we have. And next coming to this isothermal process. So, in the case of the isothermal process, there is no change in the temperature. That means the temperature remains constant throughout this isothermal process, whereas other may be changes. So, that is what we will be calling it as a isothermal process. A process in which no change in temperature occurs, we will be calling it as a isothermal process we are going to be called here. We should know about thermodynamic equilibrium. So, we should know about the thermodynamic equilibrium. So, what is thermodynamic equilibrium we should know. So, at a given state, means at a particular given state, all the properties of the system have fixed values. All the properties of the system have the fixed values. That is, if the values of even one property changes, the system's state changes to a different one. That means, in the thermodynamic equilibrium, all the values are going to be fixed, you are going to be have. So, in a system that is in equilibrium, no changes in the value of properties occurs when it is isolated from the surroundings. When it is isolated from the surroundings, there will be no change in its value of properties. Then we will be calling it as it is in equilibrium we are going to be called here. Suppose when the temperature is same throughout the entire system, we consider the system is in thermal equilibrium. That is, if the temperature is same throughout the entire system, we consider the system is in thermal equilibrium. Next, when there is no change in pressure at a point of the system, that means throughout the system there is no change in pressure, we consider that the system is in mechanical equilibrium. That means, if a system is in mechanical equilibrium, we can say that the pressure is constant, there is no change in its pressure throughout this system, then we call it as a mechanical equilibrium we will be calling. Then we have chemical equilibrium. So, in this chemical equilibrium, the chemical composition of a system does not vary with time. The chemical composition of a system does not vary with time. We consider the system is to be in chemical equilibrium we are going to be called. So, thermal equilibrium means throughout the system there is no change in its temperature. Temperature is same throughout the entire system. We can consider the system is in thermal equilibrium we can consider. And coming to the mechanical equilibrium, when there is no change in its pressure at any point of the system, we consider that the system is in mechanical equilibrium we can consider. And coming to this chemical equilibrium, when the chemical composition of the system does not changes or does not vary with time, we consider that the system is in chemical equilibrium we can consider. And if you define the thermodynamic equilibrium, a thermodynamic system is said to be in thermodynamic equilibrium if it is in chemical equilibrium, mechanical equilibrium, and as well as in thermal equilibrium, and the relevant parameters C's, that means the relevant parameters to those equilibriums will be kept constant, cannot vary with time. Then we can say that the thermodynamic system is in thermodynamic equilibrium. So, if you want to define this thermodynamic equilibrium, we can say that a thermodynamic equilibrium is said to be in a thermodynamic system is said to be in thermodynamic equilibrium if it is in chemical equilibrium, mechanical equilibrium, and as well as thermal equilibrium, and the relevant parameters constant and does not changes with respect to the time, then we can say that the system is in thermodynamic equilibrium. So, in the thermodynamic equilibrium, all these it should be in mechanical equilibrium, it should be in thermal equilibrium, and it should be in chemical equilibrium, and these parameters should not change with respect to the time. Then we can say that the thermodynamic system is in thermodynamic equilibrium we have. And coming to this laws of thermodynamics, what are the laws which we are there in thermodynamics? Mainly there are 4 laws of thermodynamics are there. So, which we call it as a zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and as well as the third law of thermodynamics. There are 4 laws of thermodynamics: zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. First, we will see about the zeroth law of thermodynamics. So, the zeroth law of thermodynamics was developed by Fowler in year 1930. So, this zeroth law of thermodynamics has developed after developing this first law of thermodynamics and second law of thermodynamics. So, it has been developed after developing the first law of thermodynamics and second law of thermodynamics, and it has been named as a zeroth law of thermodynamics. So, in the zeroth law of thermodynamics, if you want to define, so the zeroth law of thermodynamics states that if two systems are in equilibrium, otherwise we can say that if two systems are each in equilibrium with a third system, then those two systems are also in thermal equilibrium with each other. So, once again, if you define this zeroth law of thermodynamics, the zeroth law of thermodynamics states that if two systems are each in thermal equilibrium with a third system, then those two systems are also in thermal equilibrium with each other. So, here we will see how the thermodynamics, zeroth law of thermodynamics can be explained here. So, here in order to explain this zeroth law of thermodynamics, we have considered 3 systems: system A, system B, and system C. These are 3 systems which we have considered: system A, system B, and system C we have considered. So, here this system A and system B is separated by adiabatic wall. The system A and system B is separated by adiabatic wall. That means there will be no heat energy will be exchanged from system A to system B. That means the system A, in between the system A and B, there is no heat exchange will takes place, because these two systems has been separated by the adiabatic wall here. And the system C is separated from the system A and system B with diathermic walls. So here the system A and system C is separated by this diathermic walls, and as well as system B and system C is separated by again diathermic walls. So as we know that diathermic walls means in between this system A and system C, the heat can be exchanged here, and similarly the system B and system C is separated by diathermic walls. That means the heat can be exchanged between the system B and system C here. So as we said that system A and system B both are separated by adiabatic walls, there is no heat exchange between A and B or B to A, whereas system A and system C is separated by diathermic walls. So there will be exchange of heat from system A to system C, and similarly system B and system C is separated by diathermic wall. So there will be exchange of heat from this system C to system B. So therefore we can say that here A and B are separately in thermal equilibrium with C here. So here the system A and B both are in separately thermal equilibrium with C. Then we can say that these two, system A and B, is also in thermal equilibrium with each other here. So both the systems A and B are in thermal equilibrium with third system, that is system C, separately here. So because the heat can be exchanged from system A to C and system B to C. So both systems A and B are in thermal equilibrium with third system C separately here. So here we have these three systems, again A, B and C. So the system A is in thermal equilibrium with B, and system A is in thermal equilibrium with system C. So we can say that from the zeroth law of thermodynamics, system B and C are in thermodynamic equilibrium here. So here if you see about the temperatures of the systems, all the systems, so the temperature of system A is equals to the temperature of the system C here. Similarly, if the system B is in thermal equilibrium with the system C, then we can say that the temperature of the system B, which will be equals to the temperature of the system C we have. Now from these two, otherwise from these relations, from these two relations, we can say that the temperature of the system A, which will be equals to the temperature of the system B we have. So here finally all the systems A, B and C are in thermal equilibrium with each other. So if you see the significance of the zeroth law of thermodynamics. So if you see the significance of the thermodynamics here, so mainly it provides the base for thermal equilibrium. The zeroth law of thermodynamics will gives, otherwise we can say that it provides a base for thermal equilibrium. That is one significance of the zeroth law of thermodynamics we have. And also here this zeroth law of thermodynamics provides temperature as the indicator for thermal equilibrium here. The zeroth law of thermodynamics provides the temperature as the indicator for thermal equilibrium. That is the significance of zeroth law of thermodynamics we have. And one more significance which we have is thermometers functions on the basis of this law. So whatever may be the thermometers which we have, like mercury thermometers or some other thermometers, so these all thermometers will function on the basis of zeroth law of thermodynamics. So these are the three significances which we have for zeroth law of thermodynamics. And also we can say that the definition of the temperature has been given by this zeroth law of thermodynamics. So that is it provides the temperature as indicator for thermal equilibrium, we are saying that. So the definition of the temperature can be given by this zeroth law of thermodynamics only. So these are the significances which we have for zeroth law of thermodynamics. Next we will move to the another law of thermodynamics, which is first law of thermodynamics. So, if you take this first law of thermodynamics, so the first law of thermodynamics is mainly, we can say that this law is conservation of energy. First law of thermodynamics is adoption of the law of conservation of energy. Why we are saying this is a law of conservation of energy means, in this law it says that one form of energy can be converted into another form, that is main thing which we have. That means the energy form is converted into some other form. So, we can say that energy is conserved here. That is what that is why we can say that the first law of thermodynamics is adoption of the law of conservation of energy here. So, the first law of thermodynamics states that energy cannot be created or destroyed here. So, the first law of thermodynamics says that the energy cannot be created or destroyed. However, it can be transferred from one form to another form. That is what the first law says. So, the first law of thermodynamics says that the energy cannot be created or destroyed. However, it can be transferred into another form of energy. That is what first law of thermodynamics says. And also, according to this first law of thermodynamics, heat is a form of energy and the thermodynamic process obeys the laws of conservation of energy. So, we can say that from the first law of thermodynamics, according to the first law of thermodynamics, heat is a form of energy and the thermodynamic process obey the law of conservation of energy. So, that is the reason why we can say that the first law of thermodynamics is a law of conservation of energy here. So, here if you state the first law of thermodynamics, if you want to explain. So, here we can say that some amount of heat energy, that is a dq amount of heat energy, if we supply to a system, what we are doing here? We are supplying dq amount of heat energy to a system. So, whenever we supply this dq amount of heat energy to a system, so this dq amount of heat energy can be utilized in three ways. Otherwise, we can say that the amount of heat energy whichever we have been supplied to a system, that can be utilized in three different forms. So, what are those we see here? So, first when we supplied a amount of dq amount of heat energy, so first part here, a part is used in raising the temperature of the system, which is equivalent of increasing internal energy duk. Okay. So, when we supplied dq amount of heat energy to a system, a part is used in raising the temperature of the system, which is equivalent of increasing in its internal energy duk, which is increasing internal energy duk we are going to be called. And the amount of heat energy dq which is supplied to a system, it is utilized in second part. Otherwise, a part is used in doing internal work against the molecular attraction. So, whatever may be the amount of heat energy which we supplied, some part of that heat energy is utilized in order to doing internal work against the molecular attraction, which is equivalent to increase in its potential energy. Okay. Whatever may be the some part of the energy which is utilizing in order to do internal work against the molecular attraction, which is equivalent to the potential energy of the system, which we call it as a DUP we are going to be called, which we are going to call it as a DUP. So, first part it is utilized in order to increase its internal energy, which we calling it as a DUK we are going to be called, and second part it is going to be utilized in order to increase its potential energy. That means some work is doing against the molecular attraction, which we calling it as a DUP we are going to be called. So, and the next part whichever we have, the rest part of energy is used in doing external work, which we call it as a DW. So, overallly, so whatever may be the amount of heat energy which we have been supplied dq to a system, so the total amount of energy is utilized in three parts. The first part is some part of energy is utilized in order to increase its internal energy, which we will be calling it as a duk we are going to be called, and the second part, otherwise the some part of heat energy is utilized in order to doing work against the molecular attraction, which is equivalent to the potential energy of the system, which we call it as a DUP we call, and the remaining part of the energy, otherwise the rest part of energy is utilized doing some external work, which we call it as a dW, which we call it as a dW here. So, therefore, if you see the mathematical equation of this first law of thermodynamics, we have been supplied amount of energies dq, which will be equals to duk, that is increasing in its internal energy, plus dup, which is doing some work against the molecular force of attraction, which we call it as a potential energy dup, plus in order to do some external work dW. So, therefore, by combining these two energies duk dup, we can write it as a du. So, therefore, the mathematical equation of the first law of thermodynamics can be written as dq is equals to du plus dw we can write here. So, where du is nothing but which is increasing in its potential energy of the system. So, this is du we have. So, if you see the significance of the first law of thermodynamics. So, this first law of thermodynamics represents energy that can be transferred from one body to another, but it cannot be created or destroyed. So, that is significance of the first law of thermodynamics we have, and also another significance which we have is dq and dw changes throughout the process. However, throughout the entire process, this du is equals to dq minus dw remains the same. So, these are the significance of the first law of thermodynamics we have. Limitations of the first law of thermodynamics which we have is, the first law of thermodynamics will not show the direction of changes, how the direction of the energy changes, it does not show. And one more drawback or limitation of the first law which we have is, the law fails to explain the heat flow. If the heat is increased, the heat flows from one that is nothing but if the heart is heated, the heat flows from one hot end to the cold end. And one more limitation which we have is, the amount of energy transfer is only described in the first law of thermodynamics. So, we will see some applications of the first law of thermodynamics. So, this first law of thermodynamics is utilized in refrigerators, in thermal power plants, as well as some engines we have, and also some other applications like isothermal process, adiabatic process, isochoric process, isobaric process, and as well as the cyclic process. So, these are the applications of the thermodynamics which we have. So, in this session we have studied what is thermodynamics and what are the parameters which we required in order to know the thermodynamics we have studied, and then we have studied about the zeroth law of thermodynamics and first law of thermodynamics we have seen. What are the significance of the zeroth law of thermodynamics we have seen, what are the significance of the first law of thermodynamics we have seen. So, this is about zeroth law of thermodynamics as well as the first law of thermodynamics.